Yeah, how to use trig functions, trig equations to do this kind of modeling. So what we've got here is a Ferris wheel. So I recommend you draw a little picture of a Ferris wheel. And they're telling us the platform is 1 meter above the ground. So this is 1 meter. And then it says the 6 o'clock the position is level with the loading platform. So that's right there. And then let's see. It completes one full revolution every 10 minutes. And our function h of t is the height above the ground. So some things we can do here is we know at time 0, because that's when you're loading, you're one foot high, right? Or 1 meter high. And then we get these 4 turning points just like we do in the unit circle. Now it tells me that it takes 10 minutes to go all the way around. So that tells me at 5 minutes you're way up here in the car, and we know this Ferris wheel is 25 meters in diameter. So this entire line, that entire diameter is 25. So that makes, if you think about it being 25 meters high plus the 1 meter we are above the ground, that makes it time 5 minutes, the height of this car. You're at 26 feet up, or 26 meters up. Now half of that time is 2.5 minutes, and since half of a diameter is a radius, we know that this distance here is 12.5 plus the other 1 meter up, so we're at 13.5 meters. I don't know if I can squeeze that in there. Yeah, barely. So we know at 2.5 minutes up, you're 13.5 meters above the ground. At 7.5 minutes, you're back down to 13.5. And then, of course, after 10 minutes, you're all the way back around. That's why they call this the cyclic function, right? So once you get that figured out, you could make a table of values and do that. But why don't we just make a graph? Now I know 4 lines over is the full cycle, the full period. It takes 10 minutes to get all the way back down. So halfway across it's 5, 2.5, and 7.5. And we know the lowest we're going to get is 1. We know the highest we're going to get is 26. And then the midline is that midway point, which is 13.5. So now let's graph some points. At time 0, we're 1 meter up. At time 2.5, we're at 13.5 meters. At time 5, we're way up at 26. At 7.5, we're back down to 13.5, and then we're back down here at 10. Now, you could talk about this being a sine graph. I think it's easier to think about this as a cosine graph that's been reflected. Okay, so a couple things to keep in mind that this, so this is 26. So the amplitude is 26. We know it's been reflected, so I'm going to write negative 26. I also know it's a cosine graph. I don't think it's been shifted left or right because we're right on that x-axis or y-axis. So I guess the only other thing we're going to worry about is the period. Well, it takes 10 minutes to repeat, so that's the period. And if you remember that 2 pi divided by the period will tell you the b number. In this case, that would be pi over 5 x. And then it's been shifted up to the midline. Remember, we're always talking about the midline? So instead of happening down around the x-axis, this is happening at 13.5, so this is 13.5. So how do we answer these questions? We've almost done it all. The amplitude's right there, 26. The midline is the 13.5. And the period we said is 10. We got our formula for h. Then for part C, how do you find that formula? Well, we don't need to use a formula because this is a fairly simple question. 5 minutes off the ground, you're 26 feet up, or meters up, so we knew that. You could substitute 5 in there and use this equation to get it, and you would get 13, you would get the 26. Okay, so I hope that helps you. Okay, so now we got some bunnies, and this is in a Ferris wheel, so we don't have to worry about that. But we know it has an average population. There's a low in the year and there's a high in the year. And we know that it takes a full year to make a cycle. So 1, 2, 3, 4. That's December. That's June. that would be 3 months in, which is March, right? And that would be 9 months in, which would be September. And we know that it oscillates 25 above and below the average of 29. So they're telling us that this average, this midline, is 29. And it hits its lowest value in January. So in January, it's way down here at the low. 3 months later, it's at its average. In June, it's at the high. Then they start dying off back to the low in December, January. So I guess the trick is now we got to decide how high these go. Well, they're telling us it goes 25 rabbits above and below. So if we add 25 to 129, isn't that 164? And then we subtract 25, that's 104. Okay, so I guess we're set to make an equation. Again, I'm seeing a reflected cosine function because it's not starting up and it's not starting at the midline. So I'm going to write population of bunnies at based on time t is equal to negative 25 because that's the amplitude. Cosine, the period is going to be 2 pi over 12, so the b number will be pi over 6. X, or t I guess I should use. And then the midline is how it's been shifted up or down in this case. So it's been shifted up to 129. So that's an equation. You could graph that on a graphing calculator, Desmo, with these windows settings, and you would see that we did it. Now what happens if the low value occurs in April instead? Well, let's see. So that tells me it's been shifted right 4 units. So that means in July it's at its average. In October at its high. In January it would be at its back to the average. And then way down here, someplace off to the right, when's that? Next April, it would be at its minimum. So what are we seeing? Everything looks the same. It looks like, right? It looks like this graph here. It's just been shifted to the right. Won't let me just grab it. It's just been shifted to the right 4 units. So the way we deal with that is we're going to add minus 4 inside the parentheses, and it would be the same graph. Okay. So now we're going to a situation about temperature. We know that the temperature repeats every day. So that last one is 24, this is 12, this is 6, that's 18. We know that it reached 50 degrees at midnight, and then if we read a little further, we see the high and the low is 57.43. So let's draw a couple of lines here on our graph. Here's our midline. Well, since they're telling us that the low is 43, the high is 57, must be the 50s in the middle, which tells me the amplitude is 7. Let's see. So we know that the temperature 50 degrees and it starts at midnight. So 50 degrees at midnight, and then it starts cooling off till the low at 6. Then it starts warming up. Hottest at 6 in the afternoon, back down to the average at midnight. All right, so I'm seeing not a reflected cosine graph this time. I'm seeing a reflected sine graph because it starts at the midline and then goes down. Okay, so we know it's f of t or y or whatever you want to write, t of t. We know the amplitude is 7. We know it's negative because it's reflected around that line y equals 50 or around the x-axis, depends on what you want to look at. We said it was a sine graph. We know the period is 24, so 2 pi over 24 is pi over 12. It still hasn't been shifted left or right. I need an x in my equation, or a t. Write that in blue. And then I'm going to add on the midline of 50. And there we go. There's the, okay, let's see. You just find the function. So we don't have to solve it at all yet. Okay, so we got another Ferris wheel problem. We have to do a little bit more with this last sentence, so that's what makes it a little bit different why I wanted to do it. So let's see, we've got a Ferris wheel is 20 meters in diameter. That means each radius is 10. We know it loads, let's see, 2 meters above the ground, or platforms, that's 2. We know the period, it takes how many minutes? 6 minutes to go all the way around. So 3 minutes in, it's a total of 22 high. A minute and a half around, it's 12 high. At 4.5, it's also 12 high. And at time 0, it's 2 high. And at time 6, it's also 2 high. So if we think about making a sine graph for this, or cosine graph, draw our 4 turning points around. Let's see, so it's 6, 3, 1.5, and 4.5. We know the lowest this seat goes is 2. We know it's got a midline of 12. Its maximum height is 22. I know the amplitude is, let's graph some points here first. At time 0, it's 2. At times 1.5, it's 12. At time 3, it's 22. Back down to 12. Back down to 2. So another inverted or reflected cosine graph. We know the amplitude is 10. So negative 10 cosine. And it takes 6 minutes to go all the way around. So 2 pi divided by 6 is pi over 3 for the x, or for the b number. And we know it's shifted up 12. So then, there's the equation. Now they want us to know how many minutes are spent above 13. So graphically what we're doing is we want to know that x, and then we're going to subtract them. Alternatively, since the first answer we're going to get is going to be this x here, we could just ask ourselves, how long is it from that time until 3 minutes? So we're going to do 3 minus whatever our answer is, and then we're going to double it because that same time is over here, and that's the total x time where it stays above the line y equals 13. So I'm going to solve this equation for 13, and that'll tell me the places where it's equal to 13 feet high, and then, or 13 meters high, and then we'll have to find the difference. So I'm going to subtract 12 from both sides. That'll leave me 1. Then I'm going to divide by negative 10. And now I want to find out what angle this gives this to me. So what I'm going to do, I'm going to do the arc cosine of both sides of this equation. What that'll leave me is pi over 3 equals x. So then if you take a calculator, because that's not one of those nice neat numbers, do your calculator and find what the arc cosine is. Make sure you're in radian mode. Okay, so that gives me 1.6710, I guess. But that's what the pi over 3 is equal, pi over 3x is equal to. So if we multiply or divide by pi over 3, that's the same as multiplying by 3 over pi. And that's all going to be calculator work. And I got, so t, or x, equals 1.596 minutes. So now if we think about this, let's see. So we're looking for where is this Ferris wheel above, remember this is 12, so above 13 feet. So they just told me that the first time it's above 13 feet is when that will have to 1.596 minutes have passed. So now after that time it's up above y equals 13. So we're looking for how long is it up in this range. So what we can do is, if we can figure out how long this x is, all we got to do is double it to get the other part of it. So since this x right here is 3 minutes, 3 minutes minus 1.596 minutes I got 1.404 minutes, so that is this part here. So all I'm going to do is double that. So that tells me it stays above 13 feet for. So it stays above that height for 2.808 minutes. So I hope that helps you do it. So you got to write the equation, set it equal to whatever value you're looking for, solve it, and then you got to make sure you put it into context, and that's what we did here. So another sunshine or another temperature model. So we know that the high temperature for the day is 63. So that highest part is going to be 63. The low is 37. They aren't telling us the average. So if I want to find that midline for this graph, we'll subtract 63 and 37. And what is that? 40, is that 26? And 26 divided by 2 will be 13. So that tells me this, the amplitude of this graph is 13. The other thing, let's see here. I got to add 13 to 37. That's going to give me 50. So the average is 50, or the midline is 50. And they're telling us that the high temperature, let's see. The low temperature occurs at 5 a.m. So since we know normally these things repeat every 24 hours, I'm going to mark in the normal halves, not 8, 12. Then 18. So they tell us the low temperatures happen at 5 a.m. Well, normally, if we think about it, it's been happening at midnight, but that's not happening now. It's happening at 5 a.m. So it's been shifted right 5 units. So we got to keep that in mind. But so let's finish graphing these points. Notice I'm keeping it just one unit to the right of what these tick marks are that I wrote on here, because it's happened an hour earlier. So I'm seeing another reflected cosine graph. I know the amplitude is 13, so negative 13 cosine. The period is going to be another, let's see, 2 pi over 24 is pi over 12. But because I've got a shift going on here, I got to remember it's going to be t minus 5. So I got to go to the right 5. You didn't hear me almost make that mistake. Then I'm going to add 50. So that is. So I've got another temperature problem. I see that the low temperature of 37 degrees, I see it as a high temperature 63 degrees. They aren't telling me the average temperature, so I'll have to figure that out. And one way we can do that is I see that it has to increase 26 degrees to reach the highs. And if you couldn't do that in your head, you can subtract them, and you see you get 26. Now, the amplitude is half of that. So that tells me the amplitude is going up 13 and down 13. So I'm going to add 13 to my 37, and that's going to give me 50. So that tells me the midline is 50. I also know that whatever function I decide to use, I'm going to have a 13 in front of it. Then we also know, let's put some times in. Well, that's 24 hours, that's 12 hours, that's 6 hours, that's 18 hours. They're telling me that the low temperature occurs at 5 a.m. So instead of happening at midnight, it's going to happen at 5 a.m. So that tells me not quite 6. That's been shifted right 5 units. So I know whatever I put in for cosine, I know I've got some kind of period shift going on. I know I'm going to slide it right 5. Let's finish graphing this. And what I'm going to do is I'm going to go just shy of each of these tick marks. I know what happened an hour earlier, an hour later, however you want to word it. Think about it. So we know this is down here. So again, I'm seeing an inverted cosine, a reflected cosine. So I'm going to stick a negative in front of the 13, because the 13 is the amplitude, remember. I also know that the midline is 50, so it's been shifted up 50. Now the only thing I need is the period, or the B number. Since I know the period is 24 hours, 2 pi divided by 24 is pi over 12. So that's how I get that B number, pi over 12. So I'm seeing that for a function. Now what I'm going to do is assume, let's see, find an equation for the temperature D in terms of T. I think I've done that, except what haven't I done? I used X instead of T. And we don't have to do anything else with that.